Welcome to the Applied Biosystems Taq Talk video series, where we break down real-time PCR to make it easier for you. In a previous Taq Talk video, we discussed assay efficiency and how to calculate it. Now let's talk about how high or low assay efficiency impacts real-time PCR data. The aim of all real-time PCR assays is to be 100% efficient, which means there's an exact doubling of template in every cycle. We previously found that this can be calculated using a dilution series and the following equation. In order to use the delta-delta CT method for relative quantification, the efficiencies of the target and endogenous control assays must be approximately equal within 10%. If their efficiencies differ by more than 10%, you should be aware that unequal PCR efficiency will reduce the accuracy of your calculations when you evaluate the total changes. The Applied Biosystems portfolio includes well over 20 million pre-designed assays that have been validated in silico to be up to 100% efficient. That means that doing efficiency calculations for your assays is not typically necessary. However, if you do find that efficiency is outside the acceptable range, then there's likely something about the sample or setup that is throwing things off. So, what happens if my efficiency is 150%? Your first thought might be, wow, my assay rocks. That's good, right? Well, actually, no. It is not possible to be over 100% efficient, so something else is going on here. Let's review some causes of high and low efficiency and how to fix them. First, let's take a look at what's going on when efficiency exceeds 100%. Inhibitors are the most common causes of efficiencies greater than 100%. Molecules like heparin or humic acids can be carried over from the samples themselves. Other inhibitors could be contaminants introduced during RNA or DNA isolation, such as SDS or phenol. Inhibition means that even if you add more template, the CT value does not shift to earlier cycles as you would expect it to. This flattens out the efficiency plot, resulting in a lower slope and an apparent efficiency of over 100%. Inhibition is worse in more concentrated samples, so you can often see an improvement in the slope after diluting concentrated samples. This is actually a good way to recognize when inhibitors are a problem. For example, if you make 10-fold dilutions of your sample, the delta CT between each point should be about 3.3. When inhibitors are present, we see that the delta CT between our samples is about 2.8. However, it returns to 3.3 with the most dilute sample. So what should we do? Go back and check the quality of the RNA sample again by doing an A260 over A280 reading. It should be about 2. If it's not, either re-purify the sample or try again with a different method. If a new sample prep method does not resolve the issue, you may have a sample type that is inherently difficult to work with. In this case, you may consider using a qPCR master mix that is more tolerant to inhibitors, such as one of our Applied Biosystems Taq Path master mixes. What about efficiencies of less than 100%? This would mean that your template is not doubling every cycle. This is typically caused by a suboptimal reaction parameter, such as an insufficient amount of enzyme, DNTPs, or primers. Design issues are another possibility. By using commercially available reagents, you can worry less about these issues since the optimal concentrations have been worked out for you. In addition, Applied Biosystems Taq gene expression assays have already gone through a bioinformatics check for specificity. So you can be confident that the design is sound. However, if you are using a home-brewed mix or assay, you may need to re-examine these parameters. Consider changing the primer or magnesium concentration and re-evaluate your primers for appropriate melting temperatures and specificity. Okay, there's one last element to check, and that is the data itself. The alignment of experimental points on the standard curve should be verified. Here's a good curve to use as an example. Use the R-squared value to evaluate the quality of the results. Look for a value of 0.99 or higher. This is a good indicator of your pipetting skills for your technical replicates. Let's check some other data for outliers. Here's one that looks suspect. If the standard curve looks good with the exception of a point for the most concentrated sample that appears at a later CT value than expected, then it is likely that this dilution point indicates inhibition. Let's omit the point and reanalyze. We can also see outliers on the opposite end of the curve for our most dilute samples. These high CT outliers are generally the result of a low copy reaction. They're ordinarily seen at CT values above 35 cycles and can increase or decrease the slope. This is normal for samples in the 1 copy range and can indicate the limit of detection for your assay. If you have one of these types of points in your curve, you can omit and update the data. Aha! Notice the improvement in our efficiency. That wraps up our talk about qPCR assay efficiency. Check out more Applied Biosystems Taq Talk videos on our website at thermofisher.com/taqtalk.